Assalamu alaikum students. Bismillahirrahmanirrahim. Welcome you in lecture 12. And this lecture we will going to analyze a practical example. The example uh, you are looking on the screen that this is a bridge. You can say a pier shaft. This is a pier shaft. And these are piers, okay, or you can say columns. So this is a kind of a bridge deck. This is a bridge deck, and these are girders. So the load is applied on the top of the bridge, or you can say on the deck of the bridge, and the load is then transferred from the deck to the pier shaft through girders, and from pier shaft it is reaches through columns, or you can say piers, through the soil. Clear? So this is your you can say this is your foundation level. Okay, so we will now in the question it is basically tells us that assume column A and B right at this point exert only vertical reactions on the pier, okay, pier shaft. So this means that there is no any kind of fixed support, or any kind of other connectors exist there. Clear? So they are just only the column and pier shaft works like a you know like a like a Assalamu alaikum, dear students. Sorry for disturbance. Okay. So this is your, you know, this is your connection. So they they acts like a simply supports. Clear? So if you model this real problem, okay, so this will be like a W overhang beam. You can model this support as a simply like a ruler support, and you can model this like a hinge support. Clear? And then you will insert your loading. Your first loading is 60 kf, okay. Then from the support, from the support center line, this is at a distance of 1 meter, 1.5, 1.5, and from a distance. So it is symmetrical loading. The loading is symmetrical. The beam is symmetrical. Clear? So let's see how we will develop this system through grid. This is a little bit tricky system. Clear? Okay, let's see. Make sure that in which units you are working. Kilonewton. Clear? So we are in kilonewton meter. Clear? So how much grid lines are in x direction? So let's see. We will count it. Clear? This one. So in x direction, you have x1, x2, x3, x4, x5, x6, and x7. And the distances, let's say, assume 1 meter, and later we will edit that data. Clear? So we have how much? We have 1, 2, 3, 4, 5, 6, 7. So we have 7 number of grid lines in x direction, and assume that in y direction we have 1, and assume in z direction we have 1. Clear? Because this is a line object, it is not a 3D object. Clear? So assume it 1, 1. Here is also equals to 1, 1. Okay. The spacing, let's say we will assume it 1. Assume it 1, and assume this one is also equals to 1, because we are developing, or we are creating a 2D object. So we don't need these dimension, but we need these dimension in frames, 2D frame. Okay, we need z direction distance spacing as well as there. Okay, so And 2D, when we are analyzing our 2D frames, I will use Z and Z direction and Z number of grids in Z direction and spacing in Z direction. Okay, so you will understand about this. Okay, so just okay. Now this is your frame. Clear? Edit it to make, modify, and spacing. Clear? So you need that this is your grid line A, this is your grid line B, this is your grid line C, this is your grid line D, this is your grid line E, okay, this is your grid line F, and this is your grid line G. Clear? So in between AB you have 1 meter, BC you have 1 meter, CD you have 1.5 meter, and DE 1.5 meters. So you need to just modify these two grid lines. Okay, CD and DE. Let's see where it is. Where are the grids? So these are the grids. So the grids spacing between AB is 1, BC is 1, but in CD and DE, in CD we have a spacing of 1.5 meter, and between DE we have a spacing of 1.5 meter. Clear? The rest of spacing is okay. Between DE, EF is 1 and FG is 1. Okay, and after behind G, that is 0. Beyond G, that is 0. Clear? So this is spacing okay and okay. Now these two grids CD and DE 1.5 and the rest is 1. Okay, we need to develop okay a joint here and a joint here. So let's say we will use this option. Clear? We need to insert a beam from this point to this point, this point to this point, this point to this point, this point, this point, and this point. Clear? So let's say escape. Now we need to assign joints, this joint and one joint there. Okay, so let's say assign joints. I can assign two hinges, two rulers, one hinge, one ruler, give you same results. So let's say two joints. Clear? Because they are just acting as a vertical loads, both these are, and there are no lateral forces, so therefore it doesn't matter. Clear? Now we will assigning our loads. Clear? At free end, basically at the overhang portion, this is 0 and this is 1. Clear? So at free end we have a loading of 60 kilonewton. Clear? So let's say we will select this portion, assign frame load, point load, make sure this is equals to 0. Okay, modified. Okay, and now kilonewton, force add to existing, spacing at 0 you have load of 60 kilonewton. Clear? 60 kilonewton. Gravity, okay. So this is your loading. Now we will assigning the loads to the to all these beams. So that this is different points. This is different points. So we cannot assign the loading differently. Okay, we cannot assign the loads at one in one option. Okay, we need to select the beams. First we need to select this one. First, let's say I show you. Okay, I need to select first this beam, then at a distance of 1 meter there will be a load, assign frame load, beam is selected, frame load, point load, and did kilonewton add with existing, and at a distance of 0 nut, at a distance of 1 meter, I have a loading intensity of 35. Okay, so this is 35, this is 35 kilonewton. Clear? So this is load. Now I will again select 0 here, and this is 1, and again I will assign frame load, point load, add with existing, all thing are same. Okay, then select this one. Oh, this load is not properly assigned. Okay, because this is acting at a distance of 1.5 meters. Sorry. So select it again, assign frame point load, and this is acting at a distance of 1.5 meter. Clear? So okay, then assign frame load, point load, and it is also acting at a distance of 1.5 meter. Okay, 35. This is 1 meter and this is 1 meter. Clear? 1.5, 1.5. So clear? Okay, clear. So this is 1, this is 1.5, this is 1.5, this is 1. Clear? Now I will select this one, assign frame load, point load, and add with existing. Okay, and dead load. Okay, this distance is basically 1 meter. Shit. Assign point load. Okay, add with existing, and this distance is basically 1. Okay, and this load is basically 60. Clear? Okay. So the loads are assigned, joints are assigned. You will be in position to analyze the structure. Save it. This is project 3. Save it and analyze it. Clear? So this is the diagram, and this is the shift for, I think so, movement diagram. Clear? So let's see what will be the reactions. The reactions are 112, 112. Let's see, we will check it. Reactions, joints, and okay. 112, 112. So the rest of calculation will be okay. If your reaction comes out to be accurate, then your shear force and bending moment diagram will also be okay. So clear? I want to you see that once we are assigning the loads, so this beam is basically divided into portions. I try to solve this to assign the loading in somewhat like different way. Okay, let's see. Unclog the structure, because if you want to make changes in this structure, okay, you need to unlock this. Okay, this unlock button, because once you analyze the structure, then you cannot assign, because if you select this joint and you want to assign a different joints, now the joints option is disabled, it don't work. Okay, so therefore, because it is analyzed and now the structure is locked here, you cannot make any kind of changes. If you want to make changes in this beam, you need to unlock the structure. If you unlock the structure, your all results will be deleted. Your reactions will be deleted. Now if you are interested to know about your reaction, that you want to show your reactions, so now your reactions are the frame button. You can see there that they become disabled and they don't work. So therefore, because once you unlock the structure, you will lose all of your analysis data. You need to again analyze the structure, and then you will be able to show your results. Clear? Now let's see. I delete the whole beam structure. Clear? And I will delete it. Clear? And I am basically developing the beam in a different way. I first of all, I develop this one. Clear? and then I pick this point, and then I will pick this point. Now if I will select this portion will be selected separately, and if I want to select this portion will be selected separately. But you see that if I want to select, you see the selections in between B and F. Okay, so before the analysis option, at the first stage, once I was making analysis, these B, C, C, D, D, E, E, F portions are separately, they will be selected. But now they are, you cannot select them separately right now. Okay, why this kind of difference? Because if you are developing your structure and you select this option and you click there and then you click there, so this means that this whole portion is one structure. It's not a divided structure. Okay, it's not a separate structure. Okay, so if you click there and then there, this means that this portion and this portion, they are different beams, but the behavior is, the behavior is same. They work like a unique beam. Okay, not it is analyzed that this will be a different beam and this will be a different beam. No, the beam is same. Okay, the beam is same. So I want to assign the loading now to this portion. Okay, here I am trying you to explain that how you can assign the loadings through one step. Okay, so let's see point loads. Clear? Dead loads. Okay, so this one at a distance 0, there you have 0 loading, but at a distance 1 meter, at a distance 1 meter, at a distance 1 meter you have, a 35 kilonewton. Okay, and then at a distance 1.5 meter. Okay, now the distance is measured from this point. Okay, the distance is measured from this point. Okay, so at 1 you have 35. Now you need to insert, because you have to assign load there. This load, one at a distance of 1 meter you have 35 kilonewton load. Okay, and now at a distance from this point B, that is from C to D, distance is 1.5, but from B the distance is basically 2.5. Okay, the distance is 2.5, but yes, 2.5. So therefore we will, I think so, we will insert 2.5. let's see, try what will be the result. That is 35. Again we will assigning the load to D and to E, sorry. So 1.5 plus 1.5, that is I think so 1.5 plus 1.5 equals to 3, and 1, that is 4. So at a distance of 4, you have a loading intensity of 35 kilonewton. And then at a distance of F, so 4, and this distance is 1 meter. This distance is 1 meter, so 5. So at a distance of 5, you have a loading intensity. No, there is no load. At a distance of 5 meter, you have no load. Clear? You have load there, you have load there, you have load there. So let's see. This is the way. Okay, 35, 35, and 35. This is the way that you can assign loading to the whole beam. Okay, at one step. If you draw the beam in an appropriate way. Okay, like the way I did here. Okay, so at the first step we assign the load to this portion, then this portion, then this portion, and this is a lengthy way. It takes time. Okay, so although this is a simple structure, when we are basically dealing with a frame structure that is a complicated, there are so many number of members. So you think about that I have to assign loading to these members. So if they are in equal distances, or if they are in any distances but there is no support there, okay, so you can assign that beam through uh, through one uh, through one selection, okay, through one selection. So this is the way, this is a different approach I want to show you, okay. uh, Please, if you any question, any comments, please share with me on my contact, okay, okay, and watch the video and enjoy the lecture. Thank you.